6.5 day 2 is not hard. It's not bad. You already did the hard part. So, what's going to happen today is we're going to look at some other operations that require us to understand how to simplify like we did on Friday. So, here we go. This first type of problem is an addition problem. And essentially what we're trying to do is first simplify these radicals as far as possible. And in order to do that, we have to identify factors of those numbers that will allow us to simplify. In this case, we're talking about square roots. So I'm looking for the biggest perfect square that is a factor of 8. What is it? 4. Very good. Biggest perfect square that is a factor of 50. 25. So what we're going to do is just break them down. That's our first step. Now, you're going to get to a place where you're not going to have to write this step out, which is fine, but I want to show you why it works. What is the square root of 4? 2. What is the square root of 25? So I like to describe it as the 4 comes out as a 2, and the 25 comes out as a 5. It's transformational. And notice that that's the only thing that changed. This 4 was being multiplied by the radical. The 3 was being multiplied by the radical. So now it's, instead of being multiplied by the radical alone, it's multiplied by the simplified form of this factor. Okay, and then this gives me 8 radical 2, 15 radical 2, and now we're going to treat them like they are like terms. They are not like terms because in that phrase like terms applies to, usually just applies to variables. I guess it applies to constants too, so they really are still like terms. Since they both have a radical 2, what we really think is I have 8 radical 2's and I have 15 radical 2's, which means how many radical 2's do I have? 23 radical 2's. So I just add the sort of coefficients and we keep the radical like it is. Okay? Now, not all the time will the radicals match up, and if they don't, they aren't like terms, and you can't add them or subtract them. Okay. But that's pretty much part of what we're going to be doing here. Are there any questions? Next example. Please give this a shot. All right, give this problem a shot. Try to do the same idea. We've got a little subtraction mixed in now too. Obviously 3 terms instead of 2. But give that a shot and see where you can go. Biggest perfect square that goes into 12. Hello? What's the biggest perfect square that goes into 12?
4.
Biggest perfect square that goes into 27. Biggest perfect square that goes into 128. 64. Okay, so the 4 is going to come out as a 2 and get multiplied by 5. The 9 is going to come out as a 3 and get multiplied by 2, and the 64 is going to come out like an 8. Okay, so I skip that little step. Square root of 4 is 2. Square root of 9 is 3. Square root of 64 is 8. Okay, now I can multiply here. Can I combine them all together?
No.
Which ones can I combine together? The square root of 3's. So this minus 8 root 2 is going to be off on its own. Can't do anything with it. This is going to give me 16 root 3 minus 8 root 2, and that's all you can do. Okay, I don't want you reaching for a calculator and giving me weird decimal answers and stuff like that. That is not what you're supposed to do. These are exact answers, and that's how I want these answers to be written. Unless they tell you to round to the nearest whatever, you shouldn't be reaching for a calculator to come up with a decimal answer. All right, next. What do you think I'm going to have to do here? Multiply how?
-5.
What? Foil. That is correct. I have a binomial times a binomial. So you will need to FOIL. Please do that. So when you FOIL, your first step, you should have gotten this. Okay? Take a look. Make sure that's what you had. How many had that? Can I do anything more?
I don't think so.
Does 15 have any perfect squares in it? 6? 5? 2? So I'm done. Okay? If it was possible to combine like terms, quote unquote, we'd do that. But in this problem, it's not. Sometimes it will be, and it'll get you somewhere. Okay? Sometimes it won't. Questions on that? How many had that right? Good. Okay, last one. Okay, we talked about rationalizing the denominator on day one when we had a monomial. In this case, we have a binomial in the denominator. What do you multiply when you have a radical in the denominator and it's a binomial? What's it called? What's that thing that you multiply it by?
Conjugate.
The what?
Conjugate.
Conjugate. What is the conjugate of the square root of 5 minus 1? Square root of 5 plus 1. Just change that middle sign. We did this when we dealt with imaginary numbers. We did this with other fractions, okay? So if I multiply the bottom by the square root of 5 plus 1, what else do I have to do? Multiply the top, okay? So the top is distribution, the bottom is FOIL. Simplify that, please. The reason we multiply by the conjugate is because those middle terms will drop out, as you'll see. So, on top, here's what you should have gotten, okay? 2 root 5 plus 2 on top. On the bottom, I multiplied it all the way out. Of course, the square root of 25 is 5. So in reality, what I have is 5 minus 1. Okay, and some of you stopped here. When it comes to reducing, some of us are still having some issues reducing a fraction that has multiple terms on top and only one term on the bottom. It's got to be in common in everything. So if you're going to reduce here with this 2 and 4, you better also reduce here with that 2 and 4. If this was a number other than 2, then you couldn't do it. You're going to have to reduce in all of those places. You can't do partials. Okay? So since a 2 goes into all of them, I can reduce them all by 2. It's an all or nothing kind of deal. Now, I want to point something out. It is a coincidence in this particular problem that the conjugate ends up being the numerator. That is not always going to happen. You're not always going to end up with the conjugate right back on top. Additionally, it is a coincidence that the original numerator shows up on the bottom. Those two things are coincidences. That is not always going to happen. Please do not think that that's always going to happen, because it's rarely going to happen. It happened in this problem, okay?